Hello, nice of you to join me again for part 3. Now in part 2 we solve a problem with these wheels and mainly the switches passing through the holes, which I have now rectified and managed to solder these up. I soldered these up because I put the project away for the night and didn't want them falling off the board in the interim. So just make sure I got this all in camera again. I do apologise for taking everything off camera, but I don't really normally have this set up. So they now say you should take off this and put it to the side, and we're now on to LEDs. How exciting. We can now add the 2 LEDs, the instructions say. And we have a red one and a yellow one. And for those watching in black and white, the yellow one is on the right. That's an old snooker joke. And LEDs, long legged is the positive, and the short leg is a negative. So energy goes into the right hand one. Old trick, you can use a 2032 cell battery just to test the LEDs that are working before you put them in. Always good. So the instructions say LED is LED 1 is red. So now we search the board and we can see LED 1, and maybe you should be able to see if it focuses. Yes, just there's a positive just on the top there, so that's where we will insert the LED. And may as well populate the yellow one, which says is yellow. Now these will fall out, so little tip, you can just spray the legs ever so slightly, which will not allow them to fall completely down. So just make sure LED 1 and 2 in situ. Grab some solder. And what I will do is just solder one pad on each, because I know they are loose and away from the board, and as you can see they are particularly away. I'm going to steady the board, steady my hand. Get a little bit further down than that. True it up. Now this can be done if you're new to soldering or with a bit of blue tack, but just getting it on, as the old saying goes, if it looks straight it is straight. I'm not taking it off camera again. There we go. And same with the yellow. There we go, nice and flat. That's the easiest way. Obviously if you had both legs soldered then you wouldn't be able to do that. Just touch up any solder pads because the solder will lift slightly. You know what? I've left my clippers in my toolbox. Magic jump cut, and I'm back with my clippers. Got everything out. If you can hear a hum in the background, that is the soldering iron, which is relatively quite loud actually. It has a fan in the back. So that's good. Now we can move on to sheet 11 now. Also worth noting, on LEDs they have a flat side, which is the negative. So if you imagine the flat is like the minus sign on the circuit. And you can also look, not always, but how we made like a sort of hammer on an anvil. Now we need to add the audio jack, as shown in these pins are larger. So this is the audio jack. Very similar to the ones I opened on my post bag the other day. There are 1, 2, 3, 4, 5 pins. Normally there's a sort of common switching on the circuit as well. Can we, there we go. So that's fairly self-explanatory. That will point out and the holes line up. Now I think I'll just add a rest underneath there. Do one, make sure it's all square. What do they tell us about it? These pins are bigger than previous components, so it will take more solder to make a good joint. Use plenty so the jack will be firmly attached to the PCB. There we go. That's a nice conical one. And we just check that is all true and square. You wouldn't want it lift in anyway, or even on sometimes large components you can get it off on the axis, and so it's worth just checking that. If you're new to soldering, just take your time and solder one component, see how it looks. It's better to rectify mistakes on just one soldered hole than soldering it all and finding it's bad. So just 100% sure, yep, looks good. You should be able to see that focuses. Nice even conical, you know. If you can still see the top of the leg of the component sticking out with a nice sort of angled section. So you have sort of leg sticking out and then angled. That's a good joint. You have to avoid dry joints, is where the solder is up on the leg and not actually on the pad. So moving on. When it's installed the power switch, let's find the power switch. There we go. It doesn't matter which way round. There's another case that can be a little tricky to keep fully seated and vertical while you solder. So take your time and use some means of holding it in place. Be generous with solder here too. So the switch. Switches are known by abbreviations a lot of time. Single pole, double throw, single pole, single throw, double pole, single throw. There's a lot of variants, and normally you have on a switch like this a common, and then you can have 2 ins, or you can have 1 in and 2 outs. So if you're using a project, say very easy circuit, 2 light bulbs, you could have positive going in there and then obviously positive coming out either one, 2 each light bulb, and then back to negative, and then you could switch each bulb on and off. But that doesn't really apply. So the switch goes in here. There's no way of physically keeping that down for the moment. and it looks like it sits ever so slightly proud. It shouldn't be a problem. We will just double check that it all lines up with the case. I had a slight problem on the case, so oh yes, that'd be fine. Nicely raised as well. So switches. That will sit quite happily. As you may see, the legs are a bit all over the place. So we will just solder the middle leg. And you can see that's a few sheets to the wind. So holding the switch just on the plastic part, so no heat transfer. Just remelt the solder. Then we can tally the switch up. Just check that for clearance. Seems to be a bit high on one axis, so double check. Now with any large components you will want to make sure the you clean your tip. You can soon gets dirty when doing a lot of soldering. So that's our switch in situ. On larger pads they will retain more heat, so you can always be careful after soldering them. And now we're on to the battery holders. Now, are these all identical? They seem to be. This project takes AAA batteries, so they all seem to be identical. The instructions say, finally snap 4 battery clips in place as shown and solder them. They will hold themselves in place while you solder, but do make sure that they're fully seated. Again, these will take plenty of solder. Now we are done soldering, clip any remaining leads. Have we skipped a bit? Seems to not be populated with the... let's have a look. Ah yes, we can now solder the pins on. Let's do the pins first. I completely missed that one. And these are the programming pins and signal out. Fairly self-explanatory. You've got 3 up here, a 6 one here, and a what's that? Another 6 there. So we start with these. Now these have to be careful with too much heat, as the plastic body of them isn't particularly kind to reheat. So we will just balance that on there, my pliers. Just do the end one. Make sure that's all true. Seems a little bit wonky. Now as you've done the end one, you can hold the metal pins that won't be heated to just sort of gently move them. I went a shave too far the other way. Don't know my own strength. There we go. We all good today? Now let's do the 6x6. That hasn't got any polarity to it, it's just pins into a board. Now these do face up, even though this board is sort of double-sided, no component goes on to the back of a board. Let me just check that central. This seems ever so slightly off. Again, keeping your fingers away from anything hot. If you ever have burnt yourself on a soldering iron, the heat creeps up on you. It doesn't. You don't instantly know about it until you feel the pain. And that's into it. To reach the other side pins, just turn the board around, unless you're ambidextrous. There we go. So these different pins are used for programming, MIDI out, and can't remember what we have. 3 sets. Programming the board for different sounds, MIDI out, and I think the other one's a sort of connection. Looks good. Okay, now we can move on to the battery components. Now these can go one of two ways, but they're open to the front, so the battery will logically go round. So these should snap onto each other. I see they sit quite nicely once you get them in. Quite natural. There we go, nice flush to the board. Place these in. No real easy way of holding these as they go in. Suppose I could have pushed them down with a pair of pliers. See, they all are level with the board. Now all we need is solder. Now you should be able to solder these in place. In fact, I'm just going to turn up my iron ever so slightly because it's a large metal heatsink. That's why some cheaper irons, particularly quite low wattage ones, and where you don't know the temperature of them, all the heat can just get sucked out of the tip, and you end up with just solder stuck to the iron. You need something with a little bit of oomph. Like having a small car, perfectly suitable for round town, but when you stick a caravan on the back and try to go up a steep hill, you're going to have problems. With similar, like soldering irons, you try to do a big old earth plane and you're not going to find that too good. So we just soldered one leg so far, and you can feel the heat actually in the soldered components, how much it's dropping out. And we just double check that everything's still happy. Just finishing it off. There we go. You can, yeah, it's still pretty warm. Okay, so that was good. We've done the battery holders. Now, we're judging by the panels, we are actually finished. It goes on to instructions now, but we will follow this through installing the chip. If you'd be using the pre-installed software, put the jumper in position 3 as shown. So we have a jumper. We will be using the pre-installed software, so we will put it onto 3. Make it a bit easier to see. So the jumper is installed on 3. Oh, that's what the this is for, the different programming rounds. The option you're using digital pins 6 and 9 for the audio output if you're using other software. Ah, yes. So we have MIDI out, programming in, and a choice of audio out for other sort of connection devices. Now you can put the 80 mega 328 in its socket. You'll have to gently bend the pin roads inward slightly by laying the 80 meg on its side on a table and gently folding it over. So this is the brains. Just touch something earthed for a second. Turn off the soldering iron. So here we will have a dot on the chip, which is pin 1, and also a little sort of cutout, which shows very similar on the cutout on the holder. So you check your pins are straight first, and these will always come a bit angled out, and sometimes you can put them on top just to see how it goes. And I don't know if you can see that, but the legs are very much over, so we will need slight little bit of crimping in. Do this very gently with your fingers. That's better. Be a bit more forceful with it. Ah, you see, just need a little bit more. Well, I don't think that's ever coming out again. So If you ever do need to pull these out, you do need a chip puller which hooks around each side. And yanks it out. The temptation is to use a screwdriver on one side, but when you bend the pins out. So that's the little project module done. Coming up in part 4, we will fit some batteries and get the tins working. There is a choice of tins actually. So 2 tins. One is a classic Alto's tins, and one is a Marks and Sparks mint tin. So thank you all. This is part 3. Join me in part 4, and we should have this buttoned up and finished. Until next time, I'm a duty paid. Take care and goodbye.